All right, this is a video for barklord. I want to clarify. When I say physics can apply to everything, science can apply to everything, let me use a mathematical metaphor that's very meaningful to me. It's probably where I abstracted a lot of my ideas, is these mathematical metaphors. You can describe, for example, any point in space in Cartesian coordinates or in radial coordinates, right? Radial coordinates where you have the radius and the angle, Cartesian where you have an x and a y. Okay, both of those work. Okay, but the better example that I want to get into is when you have a function. And I think a human can be thought of as a function. I like to think of a human as a function, however many dimensionality it would be, that's physics. But mathematical metaphor, let's think of a two-dimensional function. Because there's continuity and there's ups and downs, I think. If you want to handle the lefts and rights, then you go to higher dimensionality, right? Okay, so any curve, like a sine wave or a parabola or any curve, can be approximated exactly with an infinite number of terms in a power series, or Maclaurin series. I always think of it as a power series is the more general term. And that's a function of the form y equals a times x plus a sub 1 times x, or let's say, yeah, a sub 2 times x squared plus a sub 3 times x cubed, and so on and so forth for infinity. And even just with a few terms, you can see this effect, because the power series will wrap the function that you're trying to wrap. There's a way to generate them and be that exact right value for a certain limit. So if I say every function can be reduced into a power series, that's correct. But it doesn't mean it's the only way. It doesn't mean that it's the best way for every circumstance. Okay? Because, for example, you can also transform into a Fourier series. Often called the Fourier transform because it's widely used. And that is where a function can, a similar thing with an infinite number of terms, the function can be simulated as a series of sine and or cosine waves added together, a series of frequencies. And this is really important. This is something we use to turn sound, which is frequency related, not perfect sine waves, which would be a pure tone, but complex sine waves added up. We reduce them into their frequencies to get the digital version and to turn it back into the frequency version. Right? And it works pretty well. So if you're fitting data, you want to see a curve that goes through some data, the closest possible curve that goes through data, you can use a Maclaurin series. Because even if it's a sine wave, you can use, a couple hundred terms from a power series and simulate it, brute force. Right? But if you're doing signal processing, you're more interested in the Fourier transform. Okay, so if I say everything can be done physically and explained scientifically, it doesn't mean it's the only way. However, I don't really know. I don't have ready-made a system that applies to everything. At least not one that isn't related to science. Because there are other things like empiricism and this perceptualism and various parts of epistemology. They all relate to, they're the epistemology of science as we understand it. Now, I could think of some candidates of things that there should always be an answer from. Poetry. The poets should always have an answer. And I could get in a similar debate. I could be saying, hey, more poets should write about, the standard model of physics. Because we need a poet's, perspective on that. And which is why I like this conversation. You get some of that kind of thing that's considered esoteric or rare or unneeded. You get the poet's take on physics. Right? I mean, we have a class they used to call in the physics department, physics for poets. We should have a poetry for physics. Right? But the reason I start off saying I don't really know a system is because, yeah, that's a pretty vague system, right? It's not like both power series and a Fourier transform are pretty technically, well explored or whatever. So I don't think there's a candidate that's as well explored, because it's hard to get group focus when exploring together. A school of literary interpretation is more isolated from other schools of interpretation, then a particular bunch of researchers are isolated from another bunch of researchers. But I fully expect these kinds of systems, and I employ them myself. Myself, rather. Uh-oh, myself, Freudian slip. So, yeah, so that's what I wanted to explain, is that since it is such a good system and it applies to everything, we should always apply it. We're always using some other system, but we have this global one that no matter what the other system is, we can apply it. And I think it always helps. And the whole technology thing, it to me is just a misunderstanding. The technology predates science. What are you guys talking about? The plow and a million different things are just, humans are inventors. Science has informed inventors because inventors are pretty clever, and then science can take them over the wall where they can use this information from science to combine with their inventor spirit and invent something. And so there's a relationship there socially, but it has absolutely no bearing on like the assertions I was making that you replied to. I don't think, because I'm talking about applying a materialist model to everything. I didn't say apply technology to everything. See. But anyway, cheers.